Hello and welcome to our webinar about structural calculation in Production Assist. In today's meeting, we will cover creating two structural systems, one time in the Production Assist desktop app and one time in Vectorworks for Production Assist. We will start with the Production Assist app and look what's possible in order to generate a small rig. A good thing to always start is to import a DWG in order to get the house points and all that stuff, so the bounding area from your rig. In order to do this, I have prepared a DWG for this in the cloud drive. I drag and drop this into the Production Assist desktop app, and it will ask me to import the DWG. I will just turn in a scaling factor because not all of the DWGs do include their scaling factor, and pressing OK. When importing this, I get an error which saying that the scaling is really, really small. If you look on here, the things have been imported, but it's really, really small. So let me delete this and re-import it with a proper scaling value. So in this time, 10,000. Pressing OK will import this, and now I have, I need to use the center option as well. Will import this and give me the proper ground floor so that I can use it. In this webinar, we will draw a small structural system so that you see how you can generate this. For this, I need a new object tool and select one of the trusses. I want to use the ProLight trusses for now, so I'm checking out ProLight H30V. Selecting it will bring me all the trusses that are available for this. I will start with a small truss in here with a 3-meter truss. It downloads me and then it's tied to my mouse. I then can click into the drawing to insert it. When inserting it, I now can just go on and insert multiple truss runs in here. What I now want is a T-corner, an L-corner. So I'm opening the tool again and searching for an L-corner. And here it is. I'm clicking on it and selecting it in here. You see, if you're moving the truss inside the Production Assist object on the truss, it will highlight this and snap it to the truss. So in this case, we want to go into the other direction. For this, I use the Shift key in order to rotate the truss about its rotation point. I can do this multiple times in order so that it then is rightly aligned in here. Pressing OK will insert this truss then. I will do the exact same thing on the other side so that it can easily insert this. Now I have my first part in here so that it's connected. Now let's go on with this and add some more trusses in here. I will use now a 4-meter piece by selecting it and snapping it to the actual trusses in here. We want to have a middle truss in here, so I select a T-corner as next thing. It's really easy if you check on this with the graphical support in here. I'm selecting this and inserting it that it's like this. I also can use the Shift key in order to rotate it so that it's perfectly aligned. When using the Control key, it also allows you to insert it with a different angle. So now the T piece is actually inserted as a T piece. For right now, I'm just fine with insert it like this, here, and here. Now we are a little bit lazy. I want to copy this 3 truss pieces in here so they are matching perfectly in here. In order to achieve this, I'm activating the Move tool and move these 3 trusses while having the Option key pressed to this here. I release it so that it's aligned, and then I have my new system in here. Another option to insert something is to use the quick keys in here. So for example, if you're selecting this in here, you can easily click and insert more trusses. Selecting the L corner in here is really easy, like this. Now we're doing the same trick again in here in order to fill this. So I'm selecting the 3 trusses, use the Move tool, rotate the view a little bit that it's nicer, and move it so that it's aligned like this. Yes. So now I have one truss system. You see the red arrow in here, which was popping up quite some time. That is the error system, which is built into Production Assist. The error system gives you real-time feedback if a system can be structurally calculated or not. It's really easy to see the errors when you're clicking on here on the rain cover. Clicking on it will show you the error. And if you click on it, if there are multiple, it will zoom the problem where it is. In order to solve this problem, well, we need some hoist, so something that actually puts this up and puts it in the roof. So what I'm doing is I'm using the new object, selecting the point insertion, and use the right symbol for this. So I will go for the supports and I will choose some of the default hoists that we have. So for example, like a 320 kilogram D8 plus motor. Selecting this will bring me this to the actual hoist, and then I just can click and insert it in here. So now you have everything that you need to calculate it. In order to see the results, select the 4 hoists, either by clicking individually on them or using the same name tool in here. So the same name tool easily allows you to select one hoist, and all the same hoist will be also selected in here. There's in same scene and same assembly group. So right now, if I'm clicking this in here, I can activate it so that it shows me the result in 3D. So I see when moving it in here, roughly the loading points are equally loaded, and most of the load is 1.5 kilonewton meter in here. The structural result in here like influence line values. If I'm clicking on the structural calculation results, influence line, I can, for example, show me the combined deflection figure. This shows me how my truss structure is actually deflecting in here and gives me a maximum value. There's also, for example, the shear force that you can see and the moments in order to see what currently stresses your trusses. What moments and what forces are, we have covered in our last webinar about the basic structural part of our webinar. The last thing which is important in here is the show workload button. The show workload shows you the workload for the specific trusses. As there is no reloads in here, the workload is only roughly 10%, so that is no problem for the actual truss to be calculated. One important fact about these values in here. Production Assist calculates the usability and the Eurocode ultimate failure at the same time. So every hoist and every other support always get filled by the usability load case, while the trusses are calculated using the ultimate failure workload. This is indicated with the green bubble that the Eurocode ultimate failure is used for the trusses, while the blue bubble indicates that the usability is used for the hoists. You can switch this by just clicking on here, which will increase the loads on the hoist, because now also for the supports, the safety factors are considered. Changing this back actually brings back the results that you want to see in order to prove if a hoist is good or not. Right now, this truss is on the ground. We want to change this by moving it up. I just pick the assembly group that is part of and move it to the ground where I wanted to have it. So for example, something like here. You see, after changing this, immediately the calculation results are updated. In order to see it more easy what I'm drawing, I'm disabling the results again and just show me the pure truss. The next thing what we are going to do is that we want to have 2 of these pieces because we want to align them to the actual house points in here. So what I'm doing is I move this a little bit to the right so that it's like this. And again, I'm selecting the red arrow, hold the Option key and move it so that I can duplicate it and have 2 of these truss systems in here. Releasing this will bring you in the new trusses, so you have 2 of them and you can insert them. Inserting loads like fixtures is really easy. Use the new object tool and select GDTF. inside the GDTFs, all the fixtures that you have on the GDTF share are available to insert. We will use a mega pointy from Roby right now. Selecting this, pressing OK, will bring it that I can insert it into the drawing. I move now to the first rig and move it so that it's connected to this. You see it's also snapping to the cords. If you use the Shift key, you can rotate it so that it's inserting at the right location. We want to insert it like this. And then I can click, 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 and click, and insert multiple of these objects. You see that every click that I'm making is actually changing the loads on the individual hoist. So by just inserting new hoist, I automatically have updated my structural calculation. You see when you are overloading the hoist, it will become yellow. If I'm now continue inserting loads, you will see at some point it will become red, which indicates that it's not properly supported. So in order to change this, I just picked the 3 lightning devices and move them to the other side. Now you see it's back again, so it's good. Now it's still yellow, which means it's above 100% workload. The next thing that is often done is that you are outpiping something, so with a specific pipe. In order to do this, I'm looking again from the top and using pipes. I use the new object tool, use the symbol, and select the pipe folder in here. There are aluminum pipes and steel pipes available. For convenience, I will choose the aluminum pipe and I will use a 1 meter pipe in here. Selecting this allows me to insert it into the drawing. I will put it into here. So right now, when I'm inserting, it is at the bottom in here. In order to move it up, select the object and move the truss so that it's a little bit more in the ball near the truss. The actual now connection between this works with a proximity. So if you are moving this in here so that it's now close to it and laying on top of each other, it will automatically insert a so-called truss cross. In order to show you that this actually changed this, I will turn on again the combined deflection figure from the calculation results. You're now seeing that the pipe is already there and that it's outpiped. Right now, I was using a lot of fixtures in order to generate load for my system, but there's also an option to use a generic weight. In order to this, activate the new object tool, use the symbol selection, and search for generic weight. If you're selecting this, anything that has a load can be represented for this, for example, if there's no symbol. Clicking on it will allow you to insert it inside the drawing. I want to insert this in here, so I'm pressing OK, and you see it automatically moves down. Important to know, you also can see if the actual pipe in here is goodly supported. And you see in here that it's at 130% workload. So putting 50 kilos like this on the truss is really not a good idea. So just let me downgrade a little bit the load and say it's only 25 kilograms. You see, that brings it again to 70% workload, which is totally fine for our approaches. So going back to the calculation results and disabling the workload again. As this is grouped in an assembly group, duplicating these pipes is really easy. Just click on this, move it like this, and then you can easily add more of this piping stuff in there at any location where you want it. And then you have it like this. As a last thing, we will insert a drop in here. A drop is something that connects 2 trusses in here. In order to generate something that can be used as a truss, we first need to insert the trusses for this. I'm selecting the symbol again, look into the open drawing, what I have, and choose the thing. I could now use again the snapping to insert this, but when I'm using the line insertion, it's actually much faster than when I would do this other ways. So I want to insert a pipe that goes from here to here. Pressing OK will insert multiple trusses at once. For sure, I don't want them to be on the ground, but I want them to be moved up. So I'm selecting the trusses, moving them out, moving them up. I also want to tilt them a little bit so that it's a little bit more like this. So it's really easy to do this by just moving it like this. You can move into the Z direction after this again with this, so that it's like this. And now select all the objects that I have into my scene and use the menu command selection, create drops. This allows me to select a drop symbol, for example, here our hoist, in order to be inserted as a drop in here. Pressing OK will insert this and will automatically update our calculation results. So now you see in here, you have the calculation results updated with the drop. Inserting trusses or inserting fixtures on the actual truss in here is also easy. Just select the fixture menu and select the mega point here again, and just use the point insertion mode in order to get the highlighting and insert the fixtures like this. So you see, you can rotate them around and they're aligned like this. So structural calculation, input the production test app is really simple in here and allows you to create fast, reliable structural calculation with the production test desktop app. So let's move to Vectorworks. In Vectorworks, like I showed last time, we have the web palette in here. The production test web palette is pretty similar like the desktop app that you have. Normally what I do is I install it right next to my Vectorworks screen so that I have the best of both worlds. Vectorworks for the drawing part and for all the other parts, the production assist web palette. So what I will do is I will draw a small system in here with lightning pipe ladders. I use the ProLight symbols again and click on them in order to generate me a small rig. All the objects that are trusses can be used also for production assist calculations in here. So doing it like this is really easy. You see in Vectorworks, the actual movement in here works a little bit different. It's using the red auto highlight. If I'm pressing the option key again in here, it allows me to also duplicate while moving something. That is also true if I'm duplicating it like this here. So if I'm selecting these 4 objects and move them around, I can insert like this. And edit. So I have my corner in here. The next step that I want to do is insert hoist on this. For this, I use the hoist tool and selecting, for example, the same hoist like we have in production assist, so the D8 plus 0.35 tons. Adding them here and here and here and here is really easy. To see the results in Vectorworks, enable the hoist objects and use the option show label. Sometimes you need to do it 2 times, or you need to be a little bit patient. And you see it automatically has filled in the actual hoist results. The next thing that we want to do is our lightning pipe ladders that we have. There's a specific tool for this, which is called lightning pipe ladder, and allows me to insert a lightning pipe. The lightning pipes is a really cool tool in order to generate such lightning ladders. You can define the height, for example, 5,000, and you can define the ladder width, for example, 1,000 to, well, let's do 500. And you can define the number of rungs. Let's use 8. So now what we have in here is this specific lightning pipe ladder. I want to move it down by 4 meters so that it's actually hanging below the truss in here. And changing to the, oh, it's still in German. Let me change it quickly to English. When changing to the plan view, you see that this has been imported into production assist as well. So what we need in here in order to make it calculate is to insert hoists now. For this, we will move, well, maybe 500 is a little bit too less in here. Oh no, it's fine. Let's let it like this. I can move this in now so that it's like this in here. The next step, what I'm doing is inserting hoists. So I'm using the hoist tool and insert 1 hoist over here and 1 hoist over here, so that I have 2 hoists actually supporting this. So that they can be calculated is working out of the box. So if I'm adding in here now the bending moment, you see, and the combined deflection, you see that this top stuff is calculated, but the bottom one is also going into the roof. To change this, select the two hoists in here and set him so that the high hook height is at 0, so that's connected with the actual truss. You see in here right now, it has connected these two things and the actual lightning pipe ladder. So the next thing that we want to do is we want to copy this. So I'm copying this lightning pipe ladder to this side, and to this side. I need to rotate this by 90 degrees. So they're aligned like this. And now move them a little bit more into the middle where I want them to have. So I'm putting them in here, and in here. Again, I will put in more hoists so that I have the proper reports for this. So clicking in here, clicking. Sometimes it's a little bit challenging with the snapping, then it's easier to use in the shading mode. Inserting in here, inserting in here, inserting in here, inserting it here, inserting it here, and wait, move more to it, inserting it here. I'm selecting all the drops that I want to use for this. And again, set the high hook to 0 so that it's connected with the actual system in here. To insert fixtures, it's really easy. Just use the fixture tool and, for example, use a vary light in here and add this to the rungs. You see in Vectorworks, sometimes it's snapping a little bit odd so that it's like this. So there's one post-processing step needed. You need to select this and change the actual X, Y, and Z rotation to 0 so they're all hanging down and actually looking like they should look. So now I have this all set it up and can calculate it really easy. The next thing what we want to do is that we're actually jumping into the roof calculation of this. So right now it is intended that this is actually on the specific roof. You can use the Vectorworks structural member tool for this. So selecting the structural member tool and drawing a structural member going from here to here, and one structural member from here to here. You even can connect it like this, so that it's combined like this. Is really easy. In order to make it properly work, for sure, you need to move it up. So I'm selecting this and moving this to 1,500 meters so that it's on top of here. There is the menu command, import structural members. This is not working in real time. You need to import it one time. After you have done this, you see this is also inserted in Production Assist, this thing. Now use the new object tool and search for supports for the roof structure. Search for ground support attachment, selecting the ground supports, and attach this to the actual roof structure in order to define the local supports of this. You see now it's actually calculating it with the supports on the roof structure. When clicking on one of the supports, you easily can look how much load actually is put onto the roof in here. So you see it's really easy in Vectorworks to draw complex structures and even including the actual roof into it. The nice thing about Production Assist is the real-time calculation part of this. In order to show you this, let me use the high 830V corner and use a really simple X corner for this in order to generate a larger system. So what you now can do is you can insert multiple of these ProLight structures, so like this, right? And move them around so that you're having a quietly larger system like this. Use the hoist tool to insert some hoists in here. Again, use something like this in here. I've picked them a little bit randomly so that I now can use the label and move them around to find a good place on how to show them. You see, this hoist here is now overloaded. In order to put a less power on this, or less force, you can move it like this in here so that it's moving around. And you see the force goes into this. So moving this, for example, in here will also release pressure on this hoist. So changing this and analyzing your structures by just moving it around and finding a good and suitable way on how to place hoists in here really helps you to arrange how in Vectorworks hoist should be placed and how you can optimize your rig. For the last thing in our demonstration, I've prepared a special file. So quickly, let me open this. What you see in here is that you're actually having structural members to the roof and bridles and hoist mixed. The problem with this is you're seeing, because the structural member on top is also bending, the trusses also go down. You see the one in the middle going down way more than the one to the right. You also have bridles that are using ropes in order to connect this in here. So what we have for this is normally something called drop compensation. With Production Assist, you can enable the objects that should be compensated. There is a button in here which is called Compensate Chain Shorten. If I'm now selecting all the bridles that I have and disable the chain shorten compensation for them, I can run a calculation to calculate it, which only moves actually the hoists up and not the bridles. So it's actually is an accurate calculation for this by using selection, edit, calculate compensated chain shorten values. And this will now level our trusses in here also with this, but will not touch the actual bridles in here, which is really easy. That was the second part of our structural calculation webinars. In this part, we learned on how to use Production Assist to generate structural calculations, to stack pipes onto trusses, and to insert loads on this. We used Vectorworks and see how the parametric object like lightning pipe ladder or bridle or structural member can be used in order to generate a calculation and get the results out of it. In the next webinar, we will look into the actual more advanced things like creating a calculation report and looking into the actual proofs of the trusses. So thank you very much for your attention. Bye-bye.